let us have a formal definition. The derivative of f with respect to x, denoted by f prime of x, is defined to be, this is the formula, f prime of x equals the limit of f of x plus h minus f of x all over h as h approaches 0, provided the limit exists. Let us see this example. Find the derivative of f of x equals 3x minus x squared using the definition. For our solution, let us write our formula here. And let us have the step 1, and that is to evaluate the function f of x plus h. It means, considering the given function here, let us substitute x plus h to all the x that we will see in the function. So we have now f of x plus h equals, the 3x here becomes 3 times the quantity x plus h, minus the x squared now becomes the square of the quantity x plus h. Let us simplify, and we have now 3x plus 3h minus, let us expand the square of x plus h into x squared plus 2hx plus h squared. Simplifying further by removing the grouping symbol, considering the negative sign here, and the final answer for step 1 is 3x plus 3h minus x squared minus 2hx minus h squared. And then step 2, solve for the derivative. Let us now substitute the corresponding value to our formula here. So we have now f prime of x equals the limit of this function f of x plus h is now the value that we solved from step 1. So we have this big polynomial we will write here, minus the f of x is the given function here. So we have 3x minus x squared all over h as h approaches 0. Please observe in our numerator that we can simplify by removing the grouping symbol, and then we can see some terms that we can cancel. The 3x here can be cancelled with the 3x there. This negative x squared here can be cancelled with the negative x squared here. Now let us rewrite our limit in simplified form. So we have f prime of x equals the limit of 3h minus 2hx minus h squared all over h as h approaches 0. Observe again that in our numerator there is a common factor which is h. Let us factor it out. So we have now h times the quantity 3 minus 2x minus h all over h. So we can cancel this h in the denominator and that common factor. Simplifying further, we have the limit of the quantity 3 minus 2x minus h as h approaches 0. Let us now simplify this limit by substituting 0 to that value of h. So we have 3 minus 2x minus 0. And the final answer is 3 minus 2x. This is the derivative that we are looking for. This is the final answer. Find the derivative of f of x equals 5x minus 2 using the definition. Let us write our formula for derivative here. And for our step 1, let us evaluate f of x plus h. Considering our function here, we're going to change every x by x plus h. So we have now the f of x plus h equals 5 times the quantity x plus h minus 2. Simplifying this, we have now 5x plus 5h minus 2. For step 2, let us now evaluate the limit formula of derivative. So we write here f prime of x equals the limit of 5x plus 5h minus 2. This comes from our step 1, and this is our f of x plus h. Then minus f of x. This is the given function, the 5x minus 2. So we write it here, all over h, as h approaches 0. Let us simplify by removing the grouping symbol of our numerator. So we have now 5x plus 5h minus 2 minus 5x plus 2. We can see that some terms in our numerator can be simplified or combined together. Look at this 5x. We have negative 5x here, so they zero out each other. The negative 2 and the plus 2 will be 0 also. Writing again in simplified form, our function now becomes 5h over h. The h and the h can also cancel out. Our function now is now simplified into a constant 5. So the limit of 5 as h approaches 0, and we have our answer, which is 5. This is our final answer. This is the derivative of our function. Let us see this example 2. Find the derivative of f of x equals the fraction x over x minus 1 using the definition. For our solution, we write again the limit formula of derivative, and then our step 1 is to evaluate f of x plus h. This is equal to x plus h all over the quantity x plus h minus 1. We can simplify our fraction here by removing the grouping symbol. So we have now our new fraction here. For step 2, let us now evaluate the limit formula of derivative. So we write here f prime of x equals the limit of this f of x plus h, and we copy this fraction in here, minus the f of x is our given function, so we copy it in here, all over h, as h approaches 0. We can see that we have a complex fraction here. Let us simplify our numerator by multiplying this fraction first diagonally down here, and then minus this denominator we multiply by our numerator of the second fraction, all over the product of the two denominators. So it will be like this. While the h in here, we will flip it up and we write here times 1 over h. Now, let us simplify our numerator by multiplying the corresponding factors. So we have here x squared minus x plus hx minus h minus the quantity x squared plus hx minus x. Now let us remove the grouping symbol and let us see if we can combine some terms. So it will be like this now. Please observe that this x squared has a counterpart of negative x squared here. It becomes 0. We have negative x and positive x. It will be 0 also. The positive hx, and we have this negative hx. If we remove those terms, we can simplify our fraction here into simply negative h. This negative h in our numerator now and the h in the denominator can cancel each other. So writing again our fraction, the simplified form into negative 1 all over this denominator. Now let us evaluate the limit as h approaches 0. It means we are now to substitute 0 to this value of h. Here we go. Simplifying further, we can now remove the 0 and we can see that this is now negative 1 all over x minus 1 times x minus 1. We can put the factors together using exponent. So our final answer is negative 1 over the square of x minus 1. This is the derivative of our function here. Let us see example 3. Find the derivative of f of x equals the square root of x using the definition. We have here again our formula, and step 1 is to evaluate f of x plus h. So we have here f of x plus h equals the square root of x plus h. Step 2, to evaluate the limit formula of derivative. So we have now f prime of x equals the limit of the square root of the quantity x plus h minus the square root of x all over h as h approaches 0. Let us now simplify our fraction here. Please remember our special product formula that a minus b times a plus b equals a squared minus b squared. We said that the factors here are conjugate of one another. So to simplify our fraction here, we want to remove the radical. So we're going to multiply this fraction by another fraction whose numerator and denominator is the conjugate of our numerator here. So we have to multiply this by square root of x plus h plus the square root of x. Take note, this is negative, so we write here positive. So the numerator here is the same with our denominator. When we multiply now these two big fractions, in the numerator, we're going to apply our special product formula. While in the denominator, we will simply put together the two denominators. So it will be like this. The limit of the square of the quantity square root of x plus h minus the square of the square root of x all over the denominator is simply putting together the h and these big radicals. Now, let us cancel out the square and the radical sign. And let us write again the fraction here. So we have now the limit of x plus h minus x all over our same denominator. We can see here that in the numerator, the x minus x becomes 0. So only the h remains in our numerator. Please observe also that there is an h in our denominator. So we can cancel the h and the h respectively. Simplifying further, we can now write the limit of 1 all over the square root of the quantity x plus h plus the square root of x. Now, let us evaluate the limit as h approaches 0. Let us substitute the value 0 to our h here. So we have now 1 over the square root of x plus 0 plus the square root of x, that we can show that this is equal to 1 over the square root of x plus square root of x. We can now put together the square root of x into 1 over 2 square root of x. This is our final answer. This is the derivative of our function here. Given the function y equals f of x, the following notations are used to denote its derivative. This is the first notation, and we read this as f prime of x. The second notation is here, and we read this as y prime. This is the third notation, and we read this as dy over dx. This is the fourth notation, and this is read as d over dx of f of x. Now, the derivative of f at a specific point x equals a is dy over dx with the subscript x equals a. And we further evaluate this by f prime of a. We understand that the derivative of the function f of x, denoted by f prime of x, is defined to be f prime of x equals the limit of f of x plus h minus f of x all over h as h approaches 0. Now, the derivative of a function f of x at the specific point x equals a is f prime of a, and the formula is the limit of f of a plus h minus f of a all over h as h approaches 0. Here are the steps to find derivative of a function at a given point. Step 1. Solve for f of a plus h. Step 2. Solve for f of a. Step 3. Evaluate f prime of a using the limit formula. And this is the formula. Note that the steps 1 and 2 are the values needed in the numerator of this formula. Example 1. Use the definition to find the derivative of f of x equals x squared plus 9x at x equals 2. Step 1. Solve for f of a plus h. The value of x here is 2. That is our a. So, a equals 2. That means in step 1, we need to evaluate f of 2 plus h. Consider our function here. We're going to change all the x on the right side by 2 plus h. So we have now the square of 2 plus h plus 9 times the quantity 2 plus h. We expand this square of binomial. So it will be 4 plus 4h plus h squared. Then 9 times 2 is 18. 9 times h is 9h. We can combine like terms. 4 plus 18 will be 22. 4h plus 9h is positive 13h plus the h squared. Then we go to step 2, and that is we solve for f of a. That means let's evaluate f of 2. Consider our function here. We change x on the right side as the value 2. So we have 2 squared plus 9 times 2. Simplifying further, we have 4 plus 18, and that will be 22. This is our value for f of 2. Now step 3. We evaluate f prime of a. That means f prime of 2. And we have this formula. Remember that the values of step 1 and step 2 are the values needed in the numerator. Substituting the corresponding values, we have now the limit of 22 plus 13h plus h squared minus 22 all over h as h approaches 0. We can remove the grouping symbols respectively. So we have like this. Let us combine 22 by negative 22. That will be 0. So in the numerator, the values are 13h plus h squared. Then notice that h is common to the two terms of numerator. We can factor it out. Numerator becomes h times the quantity 13 plus h. Now the h in the numerator can be cancelled with the h in the denominator. So we simplify further this expression as the limit of 13 plus h as h approaches 0. Let us now evaluate the limit, meaning we change this h by 0. So we have 13 plus 0, and the answer is 13. This is the final answer. Example 2. Use the definition to find the derivative of f of x equals the square root of the quantity x minus 2 at x equals 4. Note that the value of a here is 4. So for step 1, we need to evaluate f of 4 plus h. Consider our function here. We're going to change this x by 4 plus h. So we have the square root of the quantity 4 plus h, then the minus 2. We can remove the grouping symbol, and then we combine 4 minus 2. So we have now the square root of 2 plus h. Then step 2. Let's evaluate f of 4. Consider the given function here. Let us change x by 4. So we have the square root of 4 minus 2. So we can simplify this as square root of 2. Then we go to step 3, f prime of 4 using this big formula. Again, we remember that the values of step 1 and step 2 are needed in our numerator. So we have the square root of 2 plus h minus the square root of 2 all over h. We will take the limit as h approaches 0. In the numerator, we cannot simplify further the radicals. We cannot cancel anything here. And suppose we want to evaluate the limit, meaning we substitute 0 to the h. Imagine that the values will come to 0 over 0, which is what we call an indeterminate form. So, we will go to the next method. Since we have radicals, we are going to use the conjugate method. So, we will rewrite the problem in here. Let us now multiply the numerator by its conjugate. So that will be the square root of 2 plus h. This is minus, so we write here plus. And then the square root of 2. And for the denominator here, we will just copy the numerator. Now let us simplify further. Let us multiply the fractions. Numerator times numerator, denominator times denominator. In the numerator, we apply our special product. So we have the square of the quantity, square root of 2 plus h, minus the square root of 2, all over. In the denominator, we just put together the two values. So we have the h times this group. We will take the limit later. In the numerator, we can cancel the radical and the corresponding power. So we have like this, and we rewrite the numerator as 2 plus h minus 2. We can see that we can combine these 2 and minus 2. That would be 0. So in the numerator, what remains is h alone. This h and the h in the denominator, we can cancel out. So we simplify further as 1 all over the square root of 2 plus h plus the square root of 2. From here, we will apply the limit. We will change h by 0. So it becomes 1 all over the square root of 2 plus 0 plus the square root of 2. Where we simplify this expression here as simply square root of 2. We combine square root of 2 plus square root of 2, and that will be 2 square root of 2. The numerator is 1. This is the final answer.